Good evening to everyone. So today we are going to see some basic concept of thermodynamics and first law of thermodynamics. So what is thermodynamics? So word thermodynamics is derived from a Greek word thermi, which means heat, and thermodynamics means study of flow of heat or movement of heat. So to study thermodynamics, you have to know what is system and surroundings. System is a region under observation, whereas surroundings is anything other than system, and a boundary separates system and surroundings. To understand more about systems, systems are classified as open system, closed system, and isolated system. A open system is the one at which there is both mass and energy transfer. Example being a nozzle. So from a nozzle, there is a both mass and energy transfer. Closed system, there is energy transfer, but there is no mass transfer. An IC engine is an example of a closed system. In an isolated system, there is no mass and energy transfer. A flask which contains hot water is an example of an isolated system. And to study thermodynamics, we have two types of approaches, one being microscopic approach and another macroscopic approach. The macroscopic approach just see systems as an entity and derives pressure, volume, temperature of entire substance. Whereas in microscopic approach, we consider individual molecules, a position of individual molecules, velocity of individual molecules, and mass of individual molecules. So thermodynamics studying about macroscopic approach is commonly called as classical thermodynamics. That is the thermodynamics that is being taught now. And an advanced version of thermodynamics, that is microscopic approach, is called as statistical thermodynamics. Intensive and extensive properties. So for example, we are having an air or any other substance. So we are going to study property of that substance. Properties which depends upon mass of the substance are called as extensive properties. The word extensive is derived from extent. So the extent means defining a quantity. The products which depends upon extent of a substance, that is mass of a substance, are called as extensive properties. That is mass, volume, length, shape. They are all extensive properties which depends upon quantity or extent of a substance. Whereas intensive properties does not depend upon mass of the substance, such as pressure, temperature. So these properties are intensive properties. Point and path functions. Pressure, temperature, volume can be denoted in a graph sheet on a point. So they are called as a point function. They are available for a given state. For a given state, for example, for in an inlet of a nozzle, we can say that pressure is 1 bar and 27 degrees Celsius. So that is a point function, which can be defined in a given state. Whereas path function should have a process completed. For example, if I have a isentropic compression, pressure is increased from 1 bar to 10 bar. I have to give some work. So that work is a path function. Work can be given only when the process is completed. So that is a path function. Path function can be defined only when the process are completed. Whereas point function can be defined in start or end of a process. So in the start of a process, if I say pressure is 1 bar, so pressure is a point function. In start of a compression process, temperature is 20 degrees Celsius. Temperature is a point function. So now to define a path function, I have to get the process completed. So when air is compressed from 1 bar to 10 bar, I have to supply 10 kilowatt of work. So that 10 kilowatt can be supplied only when the process is completed. So that is the path function. Work is the path function. Heat is the path function. So you can see this picture. If you decode this picture, you can see a hot iron box is used for steaming the cloth. So to denote heat, I have given this picture. So what is heat? Heat is a form of energy which is formed due to temperature difference. For example, I am placing a hot cup of coffee which is at 70 degrees Celsius in a room which is at 30 degrees Celsius. Naturally, heat is transferred from the cup of coffee to the atmosphere, that is room. So heat is flowing due to temperature difference, flows from higher temperature to lower temperature. Analogous to electricity, which flows from higher voltage to lower voltage, or a fluid which flows from higher altitude to lower altitude. Heat always flows from higher temperature to lower temperature. Heat is a form of energy which is caused due to temperature difference. So you can see in this picture, so in the left hand side, we are having a pressure and volume, and we are compressing. So there is difference in volume. So what is the difference in volume causes? It is caused due to work supplied to that piston. We are pressing that piston and reducing the volume. We are supplying work. So I represent work through this picture. So I am having a gas at pressure P and volume V, and I am having a piston of area A. So I am pressing the piston and the volume of the gas is reduced, so that gas is compressed. Pressure is increased as volume is inversely proportional to pressure, and work is done on the system. So I am representing work. Work is nothing but pressure required for unit volume change, represented as area below a PV chart. Pressure is inversely proportional to volume. What is internal energy? So internal energy is the innate energy produced by a substance due to its temperature. It is mathematically denoted as CV into delta T. That is, CV is specific heat at constant volume. Delta T is nothing but temperature difference. So as represented in this picture, internal energy is energy possessed by the system by virtue of the temperature change or delta T. So first law of thermodynamics states that heat is equal to internal energy plus work. That is, heat supplied or rejected to the system is equal to internal energy possessed by the system, and that internal energy can be increase in internal energy or decrease in internal energy. If temperature is increased, the internal energy will decrease. If temperature is decreased, internal energy will increase. Right. So the internal change in internal energy plus work. Work can be done by the system or on the system. If it is a compression process, we have to supply the work. If it is expansion process, the substance will do the work for us. So based on this, the sign convention of heat and work are classified. So you can see internal energy is the heat or energy contained in the system. So if heat is added to the system, it is classified as positive heat. If heat is rejected from the system, it is classified as negative heat. Work done by the system is positive and work done on the system is negative. So that we have to change. That is, work done by the system, work coming out from the system is positive, whereas work done on the system is negative. So these are some basic concepts of thermodynamics. We'll see some other advanced topics in future. Thank you.